Let's take a look through the Understand Your Chemistry collection by previewing this lesson on weak acids and bases. Each introduction page explains the purpose of the lesson and includes a graphic to show where the lesson sits within the larger module. This is part of the Acids and Bases module, and students can see what came before, where they are now, and what they will learn about next. Each page from now on will contain a notebook icon at the top of the page that students can use to record any notes or images they'd like to remember or revisit later. This allows students to capture information in their own words and organise it in a way that makes sense to them, which is known to boost retention of information. UIC is built on the foundation of active learning, so rather than pages filled with text, you'll see content that is almost exclusively interactive questions and supportive diagrams, with rich built-in feedback that provides guidance and background information. Let's look at question 3. Students are asked to calculate the concentration of hydronium ions in cola using an equation they learned in the previous lesson. This is a great example of a spaced practice learning strategy where students recall information they've encountered previously to help solidify that knowledge and correct any misunderstandings before adding on new material. Cognitive science research indicates that spaced practice has positive impacts on long-term retention. The question is supported by an illustration that helps put some pH values in context with other everyday familiar items, connecting chemistry to real life. So it might be surprising to some that cola, with a pH of 2.6, is even more acidic than coffee and vinegar. As students answer, they gain practice using correct notation conventions for chemistry, with subscript and superscript characters. When learners select the check answer, they are shown built-in feedback that walks them through the calculation step by step. At the bottom of every page, you'll see a book icon that provides students with a summary of the key topics they've covered on the page, which provides another opportunity to reflect and review key topics. Your student might want to save these equations to their notebook, so they can copy them here and paste them to the notebook to have access to them later on. Okay, let's move on to the new content for this lesson. Again, you'll see that students are given a little primer about the page at the top, and they have access to any notes they may have saved. Each page is divided into sections, indicated by this larger heading font, so students will have a general idea what the questions that follow the heading are about. You'll see some new question types on this page with more labelling activities. Understand Your Chemistry lessons have a strong focus on math and calculations, and often begin with getting a good grasp on the equation itself, understanding what each component means before putting the equation into practice. So here, students are asked to correctly arrange the equation for the equilibrium constant. Every question is supported by feedback and set up so that students can take in the extra information and reattempt the questions as many times as needed, which can build up their confidence. Scrolling along to a new section, you'll see that every question is numbered so that it's easy for a student or educator to reference particular questions, or it gives students a specific location in the lesson to revisit at a later time. Question 5 is also a good example of a diagram that helps students understand conventional ball and stick models and how atoms physically move about during a reaction, while doubling as an interactive question where students can label the different compounds. Let's scroll down the page to show you there's a range of question types that ask students to recall information, define the relationship between components, form conclusions based on what they've learned, and of course perform calculations. This section is a great example of a series of scaffolded questions that train students how to solve more complicated, multi-step problems. Students start by defining the formula for the question, then solve for a variable using known values. Complete an ice table. Next, they substitute values and rearrange the equation before finally calculating pH. After students have attempted each individual step in these longer, complicated calculations, students can view complete workings all together by selecting a pop-up. Each subsequent lesson page will follow a similar format, giving students ample problem-solving practice with content that builds upon itself. At the end of each lesson, you'll find a Test Your Understanding and an Overview page. This is a summary page that provides more practice questions covering all of the topics in the lesson. Here is another question type we haven't seen yet, where students organise labels by category. There is a note at the top of this page that encourages students to wait a day or so before attempting the questions on this page to enhance their overall learning and memory on the topic. Another example of the spaced practice learning strategy. Similarly, the Overview page provides the same suggestion, to wait a day or two before completing the questions. However, these questions are broader in scope, asking students to recall the key overarching topics of the lesson. Each question is supported by the summary pop-up, but encourages students to put things into their own words to maximise their learning. Thanks for looking through this lesson from our Understand Your Chemistry collection.